Welcome to 10.3. We are going to take a detailed look at the ellipse. Some of our learning objectives are to analyze ellipses with center at origin. Also, when the center is not at the origin, when it's at a different point. And then solve applied problems that involve ellipses. So here is two different diagrams off to the side, one with a horizontal major axis and one with a vertical one. Just so we can refresh from our reading, we have our centers at 0, 0 for these particular examples. Our focus or foci, I'm not really sure the pronunciation on that one, I apologize, are at positive and negative C and 0. Again, this is when our center is at 0, 0. We can see our vertices focus on the value of positive and negative A as our X value. And then the major axis is the long side. The minor axis is the shorter side. So when we go straight through our ellipse, the longer one is the major. Those are important for determining all of our other points. As you can see, the focus points and the vertex points are along the major axes, and that's going to continue through this whole section. Okay, so for our first example, find the vertices and the foci for each ellipse. Here we have x squared over 64 plus y squared over 36 equals 1. So first of all, I'm just going to label that my a squared is 64 and my b squared is 36. And this is going to help us fill in all of our other points. Our vertices, when we have a function in this format, are going to be the positive and negative a, comma 0. This gives us positive and negative 8. So we have one vertex at 8, 0 and one vertex at negative 8, 0. For our focus points, we need the positive and negative C values. So we have A and we have B, let's find C. C squared is A squared minus B squared. That gives us 64 minus 36, which gives us 28. So C is radical 28. That we can simplify to 2 root 7. And since we took the square root, it's plus minus. So our focus points are the positive and negative versions of 2 root 7 and 0. Always reference back to the tables they provide you in the text. Those are really good to add to your notes. If you're creating a quick note card, that's where I would focus until you get the hang of recognizing what the vertex is or what the focus is based on what the equation looks like. Okay, for this one we have 9x squared plus y squared equals 81. So what I'm going to do is I'm going to put it in the format that we've been used to and divide by 81 on both sides. 9 over 81 reduces to just x squared over 9. And then we have y squared over 81. And 81 over 81 reduces to 1. So now it's in a form that we're used to. This tells us that my b squared is 9, my a squared is 81. So now let's find our vertices. which is 0 and plus or minus a. So we have 0, my a value is the square root of 81, which is 9, so plus or minus 9. One vertex is at 0, 9. The other vertex is at 0, negative 9. We want our focus points, and those are at 0, plus or minus c. So we're going to need to find the c value again. Remember, c squared equals a squared minus b squared. This gives us 81 minus 9, which is 72. If c is root 72, we can reduce that to 6 root 2. So we've got 0 plus or minus 6 root 2. Those are our focus points. And that's all we needed. We needed our vertices and our foci. Okay. Find an equation for each ellipse. So again, they're giving us the characteristics. We need to fill in the equation. Center is at 0, 0. Focus is at 4, 0. Vertex is at 5, 0. This is all focused along 0 here. We can see that happening. So immediately we get a big clue that it is the y value is 0. It's moving along the x-axis. So some of the other information, let me see. There we go. We can see this value here in this focus is our c value. So we are automatically able to notice that c is 4. In our vertex, we know that that value is a, so a is 5. So that's really, really helpful. Our general form of our equation is going to be x squared over a squared plus y squared over b squared equals 1. And so we have a squared is going to be 5 squared, so x squared over 25 plus y squared, and we don't know b, so we need to find b. B squared is a squared minus c squared, so that's going to be 5 squared minus 4 squared, 25 minus 16, which is 9. So b squared is 9, and that equals 1. So now we have filled in our a and our b. We have our equation. Okay, this one has our focus points are at 0, 4 and 0, negative 4, and the length of the major axes is 14. So, because our focus points are where our x is 0 and it's moving up and down the y, we know that our major axis is along the y-axis, so that immediately gives us our general form of our equation, x squared over b squared plus y squared over a squared equals 1. Another thing that really helped me out when I'm trying to figure these out is getting just a general drawing, and we know that we have a length of 14, which means it's going to go up to 7 and down to negative 7. And since our focus points are at 0, 4, and negative 4, we have something happening like this. this gives us our information of our 0a value at 0, 7. And then here we would have our b value in 0. So we have our a. Let's fill that part in. Y squared, our a is 7. 7 squared is 49. We need b squared. So let's use b squared equals a squared minus c squared. This gives us 7 squared, and c is given to us right here in the focus. So we have minus 4 squared, so 49 minus 16, which is 33. That's our b squared, so that goes under our x squared. X squared over 33 plus y squared over 49 equals 1. That is our equation. Another cool thing I'm going to mention here is that if you wanted to double check that your equation is the right one, if you put this equation exactly as it is into Desmos, it will graph it for you. Your graphing calculator will have trouble trying to process what this means, but in Desmos, they have a really nice program that will allow you to put it in as it is, and it'll graph it, and you can double check that you're hitting all the points on here that we kind of sketched out. So that's really nice. Okay. Next up, find an equation for each ellipse. We have the center at -3, 1, the vertex at -3, 10, and the focus at -3, 6. Our center, we know, gives us h, k. Our vertex has h, and then we know that that 10 is k plus a. Our focus still gives us h, and we know that that 6 is k plus c. So we have a little bit to figure out, but we've been given a load of information that we can use. So my sketch, just to get an idea, we have our center at 3, -3, 1. So we're working over here. I'll move it over. That's where the center is. Our vertex, -3, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is up here. And then the focus is -3, 6. 1, 2, 3, 4, 5, 6. So the same amount of space away are the other focus and the other vertex. So this one is going to go 1, 2, 3, 4, 5, 6, down to here. Okay, something like this. I don't really know how wide this ellipse is, but this gives me an idea. So I'm moving up and down the y-axis on the major axes of this ellipse. This tells me my general form of my equation is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. So let's fill in what we know. We know our h and our k so far. So we have x plus 3 squared and y minus 1 squared. Now, in order to get my a and my b, first what I'm going to do is I'm going to say, I know that k plus a equals 10, and k is 1, so 1 plus a equals 10, which means a has to be 9. So we have 1, and I also know that k plus c equals 6, and k is 1, so 1 plus c equals 6, so c has to be 5. Now neither of these gives us b, so we're still going to have to solve for b. B squared equals a squared minus c squared. This gives us 81 minus 25, which gives us a 56. Now we were looking for b squared and a squared. So let's fill in our b squared, that's 56. Our a squared is 9 squared, so 81. And now we have all of our pieces and we have an equation. Next up, our foci are -1, 2, and -1, -4, and the length of the major axes is 14. So again, let's label some things. This is our H. This is our K plus C, and I'm going to put this one as the K minus C because it is smaller. Our major axis is 14 units long, and we see that both of our focus points are along that -1, so that tells us it's going vertically. The major axis is parallel to the y. So what would this sketch look like? Oop. Okay, let me just... Oh, I keep putting it way too close. Okay, we'll put it here. All right, -1, and then we have it at 2, and -4. Now from -4 to +2, if we go to the middle of these two things, we're going to end up at -1, -1, which is our center. It splits the two. Our major axis is 14, so from that center, we're going to go up 7, 1, 2, 3, 4, and down 7, 1, 2, 3. Those are our vertices. So we have something maybe like that happening. Now, since the major axis is parallel to the y-axis, that tells us our general form of our equation is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. We know that our h is a -1, so x plus 1 squared. And we know the k, we don't know the k yet. Okay, so let's figure some things out. if we know that h is -1, we want to find k. What I'm going to do is I'm going to list out, I have k plus c equals 2 and k minus c equals -4 from our focus points. We know that. One of them is k plus c, one of them is k minus c. So if I just use what I know about solving equations, if I add these two things together, I'll have 2k, c minus c is 0, and 2 minus 4 is -2. This tells me that k is -1. So if k is -1, then we have y plus 1. Now we can figure out what is our c value, because we know that k plus c equals 2, k is -1, and -1 plus c equals 2. That means that c must be a 3. And you can double check that with the other one. K minus c equals -4. -1 minus c equals -4. That means that c must be a 3. So it checks out. We have our c value. So now, one of the things that we know, I'm just going to kind of back up here and say we're given the a value, but in like a roundabout way. Our a value, remember, is on our major vertex. So we know, since this goes up 1, 2, 3, 4, 5, 6 to 6, we know that we have our vertex. So the vertex, let's see, I'm running out of space, but our vertices, I suppose, yeah, I'll put V. Our vertices, we have them marked at -1, and then we have +6, and we have -8. Because we're not on the origin, we're shifted onto a different point. So the vertices tell us not only is this the h, but this is k plus a, and this is k minus a. So we're kind of given our a in a roundabout way. So if we do almost the same sort of thinking and say, okay, this is telling me that k plus a equals 6, and I know that k is -1, so -1 plus a is 6. That means a has to be 7. I can double check with the other one as well. It should come out the same. K minus a equals -8. K is -1. -1 minus a is -8. That means that a must be a 7. So we have a, and if a is 7, that means that a squared is 49. We have a c, so let's just find the b. The b is b squared is a squared minus c squared, which is 49 minus 9, which is 40. So b squared is 40. And that's our equation. Okay. Example, our last example is another application problem. A hall 120 feet in length is to be designed as a whispering gallery. If the foci are located 35 feet from the center, how high will the ceiling be at the center? So what we're looking at here is something like a room, and the ceiling is kind of like doming, and we have 120 feet long. So if we have the origin here, that means half of the room goes to 60 and the other half goes to negative 60. And the foci, it just gives it to us, is at 35. So we have 35 here, same over here. So what are some things that we know? Well, we know that this is our A value. We know that this is our C value. And we want to know how high is the ceiling. So this value up here is going to be 0 and B, the height of this ceiling. So we need to find B, and we know that B squared equals A squared minus C squared. A is 60 and C is 35. So 60 squared minus 35 squared is 2,375. So if we take the square root of that, B is about 48.73. So the height of the ceiling at the center of the room is about 48.73 feet tall.